Okay, so let's do a quick review of synthetic division and regular polynomial long division. So let's take x cubed plus 5x squared minus 12x minus 36 is divided by x plus 2. Okay, so two different ways to go through this. Let's look at the long division first. So this means x plus 2 goes into x cubed plus 5x squared minus 12x minus 36. Let me rewrite this so it looks good. Okay. And I think it's important to remember just the regular old division algorithm because we're doing the exact same thing. So for example, 2 goes into 7 3 times, right? Then we multiply. 3 times 2 equals 6. Then we subtract. 7 minus 6 equals 1. And then you try to divide again. Because 1 is smaller than 2, we know we can stop the division and that this number becomes my remainder. So a couple of things. For one, what does this mean? And what are these things called, right? This, the answer, is called the quotient. This number is called the divisor. And this guy inside is called the dividend. Okay? So what is true is 3 times 2 plus 1 equals 7. I'll write that again. 3 times 2 plus 1 equals 7. So that means the quotient times the divisor plus the remainder is equal to the dividend. Right? So quotient times divisor plus remainder equals the dividend. Another way to write the remainder would be to say that my quotient is 3, and then we write the remainder over the divisor in 1/2. Okay? So a couple different ways to write that. So we apply that same logic to the polynomial long division. It's the same algorithm. Okay, so when we start, I would say take the leftmost term and make sure your terms are in, descending order into the leftmost term of the dividend. So really, x goes into x cubed how many times? And another way to think about that is what times x is equal to x cubed. And that would be x squared, because remember, we're multiplying here, I add exponents when I multiply like bases. So this would be x squared. So then we multiply, just like we did over here. But the x squared has to get multiplied or distributed to both terms of the divisor. So x squared times x equals x cubed, and x squared times 2 equals 2x squared. And you always want to make sure that your like terms line up. So cubes are under cubes, squareds are under squareds, because then I can subtract. And I always take this just one column at a time. So x cubed minus x cubed equals 0. 5x squared minus 2x squared equals 3x squared. And then bring down the next term, which is minus 12x. And then we do this process again. So x goes into 3x squared how many times? Or what times x equals 3x squared? Well, that would be 3x. So plus 3x, and then we multiply. 3x times x equals 3x squared, and 3x times 2 equals 6x. And now we subtract. Again, I'm just going to change color to keep this straight. So this is 3x squared minus 3x squared, which is 0. This is negative 12x minus a positive 6x. So be careful. The signed subtraction is what I think gives people the most trouble. So look at what we're doing. We're saying negative 12x minus a positive 6x. That's the arithmetic that we're doing right here. So that would be the same as a negative 18x. Bring down the next term, which is a negative 36, and then we do the division again. X goes into negative 18x, negative 18 times, whoops, my pen is being a little weird. So negative 18 times x equals negative 18x, and negative 18 times 2 is negative 36. So this actually divided evenly, right? So my quotient is x squared plus 3x minus 18. We don't need to do anything with the remainder because it's 0, but just for the extension here, you could say then plus the remainder over the divisor. I said typically if the remainder is 0, we would just leave that as 0, but if it was a number other than 0, you would add it again with the remainder over the divisor, just like we did over here with 3.5. Now, the other option is, here, I'm just plugging in my computer, is synthetic division. So when we're using synthetic division, sometimes people prefer it because it could go a little bit quicker, but your divisor has to be a degree 1 polynomial. So it has to be in the form of x, plus something or x minus something. So your divisor has to be in this form to use synthetic division. So in this case, ours is. So we can set it up using synthetic division too. So let's go ahead and do that, and then you can have a good example of both to practice. Okay, so if we're going to set up synthetic division, we're going to take the opposite of this number to the outside. So since that's a positive 2, the 0 would actually be a negative 2. So that's what I pull on the outside. Had that been x minus 2, I would have used a positive 2. And then I just pull the coefficients of the dividend. So the first coefficient, the number in front of the x cubed, is 1, and 5, negative 12, and negative 36. So basically, I'm just doing this division with just the coefficients. So to start, we bring down the 1 on the left, and now I multiply to the outside, and I add the columns. So 1 times negative 2 is negative 2. 5 plus negative 2 is 3. And then we multiply again. 3 times negative 2 is negative 6. Add the columns. I get negative 18. Negative 18 times negative 2 is 36. I add the columns, and we get 0. So 0, this is my remainder. And then this represents my quotient. The constant term has no x. The 3 gets x, and the 1 gets x squared. So we can see that my quotient is x squared plus 3x minus 18. And again, that's exactly what I got up here.